Alright, welcome back. So, this is lecture 5 in this course on mathematical tools for cognitive sciences. Now, in this lecture, I'm going to introduce functions. So, what is a function and how do we denote a function and some important properties of a function. Okay? And this lecture will set up the basis for next few lectures where we will talk about different kinds of functions, for example logarithmic functions, exponential functions and trigonometric functions. Okay. So function is actually a process. So you can think of function as a process. So function is a process that takes some input and gives you exactly one value as an output. Okay. So function is a process that yields exactly a single value as output based on some input. Okay. So think of some process f. Okay. So f is a process which takes some input value x and would give you some output value, let us say y. So you can write this as y equals to f of x. So this is how we denote a function. So f is a function, x is the input and y is the output. Okay. So this is the most important thing or most fundamental thing about a definitional thing about a function, that it is a process that takes some input and gives you a single value, exactly single value as an output. In a way, another way to think about this is that there is, let us say, a set of possible values of x, set of possible input values, let us say 1, 2, 4, 5, 6. Okay. So function is a process that maps these input values to exactly one output value. So let us say 5, let us say 6, let us say 8 and so on, right. So function is a process that takes an input value and yields an exactly single output value. Okay. Now, but what is exactly a function? So how can we take some examples, right? So let us say this. Let's say you have a function f which takes an input, let's say x, and gives you output x square plus 1. Let's say this is the output. So it takes the input x and gives you this output. What does this mean? So let's say if it takes the input 1, then the output would be 1 square plus 1, 2. If it takes the input 2, the output would be 2 square plus 1, 4 plus 1, 5 and so on. Okay. So this output that you are seeing here is a function of x. Okay. So you are applying some process, you are applying some operation on x to get this output, whatever we are seeing here. Okay. So there is a way to write this. What you can write is this, that f of x is equals to x square plus 1. What does this say? That this f is a function and this is a function of x. Okay. And what would be the value of this function? How this function would give you an output? X square plus 1. So when you write a function like this, so this is a way to denote a function. So using a small capital letter, it could be f or g of x or h of x, right? So we typically use a small alphabet, not capital, but a small alphabet, f, g, h, like that. And inside these round brackets, we write the input variable. This is the input variable. And on the right hand side, we write what would be the outcome. Okay. So what exactly this function does. So what would be the value of the function. Okay. So when we write this function f of x equals to x square plus 1, what do we mean is this, that there is some input variable x. Okay. And depending on the value of this input variable, the function will yield exactly some output value, right? And that output value will depend on this form, whatever is written on the right hand side, x square plus 1, right? So, let us say input value is 1, 2, 4, the output corresponding output value will be 1 square plus 1 2, 2 square plus 1 5, 4 square plus 1 9, like this. Okay. So, this is another way of looking at the function. So, you can call function, you can say that function is a mapping from an input variable x to some outcome variable, let us say y, okay, such that there is exactly single value of y corresponding to a particular value of x, right. So, this is an example of a function. So, function in a way also gives you relationship between an input variable, let us say x, and output variable y. Okay. So, there are two variables in action here, one is the input variable and one is the output variable. So, when you have two variable system, you can draw it on a two dimensional graph. So, you can always draw the graph of a function. So, let us say the function is f of x equals to x square plus 1. Can you draw the graph of this function? Yes. So, on x axis, let us take values of x. Let us take the input variable on the x axis and take the values of the function f of x on the y axis. So, corresponding to some value of x, f of x would have some value, right. So, let us say when x is 0, what would be the value of function f of x? What would be the outcome? When x is 0, outcome is 1. So, f of x is 1 when x is 0. When x is 1, then outcome is 2. When x is 2, then outcome is 5, and so on. The same thing will happen on this side. Okay. So, this is how you can draw the graph of a function. So, this is graph of the function f of x equals to x square plus 1. Okay. So, even when you are given some equation, let us say 2x plus 3y equals to 2, this is equation containing two variables x and y. Okay. Now, you can write this equation as a function if I tell you that x is some input variable and y is the outcome variable, right. So, y is the outcome of the function, x is the input. You can write this equation as a function. How? So, first write this equation in form of y. So, 3y is equals to minus 2x plus 2, y equals to minus 2 by 3x plus 2 by 3. Okay. So, outcome variable is equal to minus 2 by 3x plus 2 by 3. So, this gives you the relationship between outcome and input, right. So, you can write this as a function. So, you replace y by f of x. So, this becomes 2 by 3x plus 2 by 3. Okay. So, now this is a function of x. Okay. You can also have a function of multiple variables. You can have a function of x and y, something like this, x square plus y square. Okay. Now, this is a function of two variables x and y. Okay. This is a function of one variable, only x. Okay. Now, there are important concepts about functions that you must know, and that becomes very critical for our further understanding of functions. One, whenever we define a function, let us say f of x, okay, which maps some values, input values x to some outcome values, right. So, let us say your function is f of x, okay. So, it maps in some input values to some outcome values f of x, right. So, let us say this is the function f of x. Now, for this function, you can figure out what possible values x can take, what possible values the input variable can take. Okay, what possible values x can take, and second, what possible values f of x can take. Okay. So, what are the possible values that x can take and what are the possible values that the function can take, f of x can take, basically the outcome can take. Okay. So, what is the possible range of values of input and what is the possible range of values of output, right. So, what possible values x can take, this thing is called domain of the function, and what possible values f of x can take, this thing is called codomain of the function. So, there are two important concepts in understanding functions: domain of the function and codomain of the function. Okay, so, what possible values x can take, what possible values f of x can take. Okay. So, typically let us say a very simple function would hold for all real values such that x can take all real values, y can take all real values. Okay. What kind of function would hold for all real values? So, let us say y equals to 3x plus 2. So, let us say function, let us say it is about a straight line. So, function gives you, it is a linear function of x, right. So, you can say it a linear function, f of x equals to 3x plus 2. Okay. So, this is a function of x. In this case, x can take any real value as well as this function can also take any real value. So, when you draw the graph, this is how it looks like. Okay. F of x here and x here. Okay. So, this line extends in both directions. So, x can take any real value as well as y can also take any real value. Okay. So, this is how the domain and codomain of this particular function looks like. But for certain functions, it is possible that x cannot take all real values. Can you think of an example where x cannot take all real values? Consider this function f of x equals to 1 divided by 1 minus x. Can x take all real values here? Let us see. Now, interestingly, this thing is in denominator, and this is something I discussed in the previous lecture as well. When you have a term in the denominator, it cannot be equal to 0, because if it is equal to 0, then you won't be able to evaluate this function at all. You won't be able to evaluate this term, right. So, this function would be undefined when this denominator term is equal to 0, then the function would be undefined because this whole term would be undefined. So, what does this mean? 1 minus x cannot be equal to 0, and this requires that x is not equal to 1. So, x cannot be equal to 1. So, x can take any real value except 1. Okay. So, that is the domain. What would be the codomain of this function? What would be the codomain? Can y take all real values? Well, let us see. If you are not sure, you can draw a graph and see for yourself how the graph looks like, right. Let us see. So, let us take corresponding values of x and y for this particular function x f of x. Yeah, this is how I would write it. So, at x equals to 0, the value of f of x is, the value of the function is 1. When x is 1, function is not defined. When x is, let us say, close to 1, let us say 0.9, then the value of the function would be 1 divided by 1 minus 0.9, 1 divided by 0.1, 10. Basically, actually the value of the function will increase as the value of x gets closer to 1. Okay. What would be the value of the function if x is equals to 0.1? Then the denominator term would be 0.9. So, 10 by 9. So, around 1. So, slightly greater than 1. Okay. Slightly greater than 1. But as x gets close to 1 but less than 1, then this becomes a very large value. Okay. What about x is slightly greater than 1? Let us say 1.01. If x is 1.01, then the denominator is 1 minus 1.01 minus 0.01. So, you are looking at minus 100. So, you are getting a value like minus 100. Okay. So, it is a large negative value. Okay. And as it gets closer and closer to 1, but slightly greater than 1, this would be a very large negative value. Okay. So, tending towards negative infinity. Right. So, the graph would actually look something like this. So, at x equals to 0, the value of y is 1. At x equals to 1, the graph is undefined. So, let me draw a vertical line at x equals to 1. Okay, this is the line depicting x equals to 1, right. So, the graph is undefined at this value, but as you go from x equals to 0 to x equals to 1, the value of the graph keeps on increasing, right? So the graph is going something like this, but as it gets close, very close to 1, the value would tend towards infinity. So it becomes very large, right? And if you take values above 1, then the graph would look something like this. Would it always remain negative if x is greater than 1? Yes. If it is very large value, let's say 100, then you would be looking at something like 1 divided by minus 99. So the graph would look something like this. Okay. But what would happen if x is negative? So let's say x is minus 0.1. Okay, then this is 1 divided by 1.1. So you are looking at 10 by 11. So this value is slightly less than 1. Okay, so the values are going downwards. What if it is close to, let's say, minus 0.99? Then this would become 1 minus 0.99, 1 by 1.99, so 100 by 199, so around 0.5, right? So y is around 0.5 here, and when x is 1.99, when x is greater than 1, 0.99, okay, minus 0.99. Okay. So somewhere like this. Okay. So actually, the point is, if the value of x keeps increasing in the negative direction, would the value of y would ever become negative? No. So value of y would always remain positive. As x keeps on growing in the negative direction, the value of y would decrease. Okay. So the graph would look something like this, in this direction. Okay. So this is the graph of the function 1 divided by 1 minus x. So you can try it yourself, how exactly we got this graph. This is a very interesting graph. Okay. So this is the graph of 1 divided by 1 minus x. Now you tell me, what is the domain and codomain? So are all values of x possible? So all values of x are possible in this direction. It can take all negative values, it can take all positive values greater than 1. Only thing that is not possible is x equals to 1. But are all values for y possible? It seems y equals to 0 is not possible. Okay, so y cannot take the value 0. You can say this in this graph. Okay, is there a particular region? So one thing you can see is this, that let us plug in y equals to 1 divided by 1 minus x. I just replaced f of x by y. Now let us solve this equation for x. Okay, so 1 minus x is 1 by y. What would be x? X would be 1 minus 1 by y. So that is y minus 1 divided by y. Okay, or you can have just this as well, right? Y minus 1 divided by y. Now this thing, the value of x would be undefined when this denominator is equal to 0. Okay, so this is not possible when y is equals to 0. Okay, so this is we are solving it for the codomain. Okay, so the codomain would be such that y can take any value except y equals to 0. Okay, this is how we find the domain and codomain of a function. Okay, so these two are very important concepts about a function. Whenever we see a function, we should be able to draw the graph of a function. We should be able to find its domain and codomain. Actually, it would help if you find the domain and codomain first. You find all the critical points of the graph, all the critical points of the function, and then you draw the graph. Otherwise, it becomes slightly tricky to draw the graph. Okay. Okay. Let us take a couple more examples. Let's say the function is 1 divided by 1 minus x square. We took a similar example in the previous class, but now we want to find the domain and codomain of this function. Okay. Let us begin with domain. Okay. What possible values x can take? Now, here as well, if this denominator is 0, the function would be undefined, right. So, we cannot evaluate this function when this denominator is 0. So, 1 minus x square can't be equal to 0. That means x square can't be equal to 1. That means x can't be equal to 1 and x can't be equal to minus 1. Okay. So, x can take any real value except 1 and minus 1. Good. What about y? What possible values y can take? Well, first thing you can do is plug in y by replacing f of x, and let us try to solve it for x. So, 1 minus x square is 1 by y, okay. X square is 1 minus 1 by y, right. X is y minus 1 by y square root, okay. So, one thing that does not seem possible here is that the y would take any value equals to 0, similar to the previous problem. Y cannot take a value equal to 0. Also, because this is a square root, okay, well, you can understand it in two ways. Because this is a square root, so we cannot have a negative value inside, otherwise it won't be a real number, it would become an imaginary number, okay. But there is a simpler way as well, because this is x square. So, if it is x square, the value of this term would always be greater than equal to 0. It cannot be negative if it is a square, right. That means 1 minus 1 by y has to be greater than equal to 0. Okay. Now, what does that imply? Let us try to solve this. That means 1 by y should always be less than equal to 1. That is the only way this thing can be greater than equal to 0. Now, if 1 by y is less than equal to 1, okay, then y has to be what? Then y has to be greater than equal to 1. Okay. So, this statement would hold only if y is 1. In that case, it would hold because 1 would be equal to 1, or if y is greater than 1, let us say y is 2, then this term would be 1 by 2. So, this would be less than 1. Okay. So, this statement would hold only if y is greater than equal to 1. That is your codomain. So, your codomain is such that y is greater than equal to 1. So, y can take any real value which is greater than or equal to 1. And what was the domain? That x can take any value except x equals to 1 and x equals to minus 1. Okay. So, these are the domains and codomains. Now, it would be easier to draw the graph of this function. Now, you already know something, that y cannot take any value less than 1, x cannot take 1 and minus 1. What is the function? F of x equals to 1 divided by 1 minus x square. So, let us try this. Let us try some values. Let us say what would be the value of the function at x equals to 0. So, when x is 0, the function would be 1 divided by 1 minus 0, 1. And what would be the value of the function when x is, let us say, close to 0, but not exactly 0. So, let us say 0.1. When x is 0.1, x square is 0.01. So, in the denominator you will get 1 minus 0.01, that is 0.99. So, you are dividing 1 by 0.99. So, this value would be slightly greater than 1. So, basically the graph is increasing, okay, and which is expected, because see, the codomain is y has to be always greater than equal to 1. So, graph is never going to go below y equals to 1. So, graph will always be above this line, above this y equals to 1 line. So, graph is increasing, which is expected. What if you take x equals to 1, then the graph is undefined. Okay. So, let us draw this line x equals to 1 here. This is x equals to 1. Also the graph is undefined at x equals to minus 1. So let me draw another line, x equals to minus 1. So graph is undefined at these two values. So what would happen if the value of x is very close to 1 but not exactly 1, let's say 0.99. So when x is 0.99, the square root would be somewhere around, let's say 0.95, right, or 0. Yeah, let's say 0.95. So that would be 1 minus 0.95 would be 0.005. So 100 by 5, 20. So it is increasing. So it is a very large value when x gets closer to 1. So the graph would look something like this. So as you go closer to x equals to 1, the values will keep on increasing and would grow very large. Similar to when you go closer to x equals to minus 1, this will keep increasing and this would grow very large. Okay. Now, what would happen on the right side of x equals to 1 and on the left of x equals to minus 1? Let's see. What would be the value of the function if x is slightly greater than 1, let's say 1.01. Okay, so if x is 1.01, its square would be let's something greater than 1, let's say 1.0012 or something. If you subtract it from 1, then the value would come out to be minus 0.01 something. Okay, so this would be a negative value and a large negative value. Okay, so the graph would look, wait a minute. So if x is greater than 1, let's say 2, then the value of the graph would be 1 divided by 1 minus 4. So 1 by minus 3. Okay, I think we have made a mistake in calculating codomain. So anyway, let us try to draw the graph first. So if x is so if x is, let's say if x is close to 1 and but slightly greater than 1, okay, then the denominator would be slightly negative and that would make the overall term large negative, right? And if the value of x is very large, let's say 100, then the denominator would be very large negative value that would make the function would have very small negative value. So the function should behave something like this for x greater than 1. Okay. And a similar thing would happen on this side because this graph is symmetric, because you are dealing with the term with x square in it, right? So regardless of whether x is positive or negative, when you take this square, the function would have the same value. Okay. So the function would be symmetric around the y-axis. Okay. So this is how this graph looks like. Okay. Now I think we made a mistake in calculating codomain somewhere. So this y equals to 1 by 1 minus x square. So 1 minus x square can be written as 1 by y. X square can be written as 1 minus 1 by y. Okay, 1 minus 1 by y has to be greater than equal to 0 because x square can never be negative. So in what ways this term would be greater than equal to 0? So if y is greater than 1, then always this would be okay. So there is also another way. If y is negative, then this will also work actually. Right. So we ignored this thing that, so the condition that should be satisfied is this. Okay. So in what ways this term would be greater than equal to 0? So one way is this, that well somehow if this value is greater than 1, this value of 1 by y, okay, if this value is greater than 1, then this entire thing becomes negative. So, then it can't be greater than equal to 0. Okay. But if this term is less than 1, let us say between 0 and 1. Okay. So, if 1 by y is between 0 and 1, okay, and even if it is 1, then everything is fine. Okay. If 1 by y is between 0 and 1, then everything is fine, then this statement holds. Okay. But this is not the only way this can work. This can also work if 1 by y is actually negative. Okay. If it is negative, then it is also fine, because if 1 by y is negative, then 1 minus some negative term then becomes a positive thing, right. So, basically what you can say is that if 1 minus 1 by y is greater than equal to 0, then 1 by y has to be less than equal to 1. If this statement holds, then there is no problem. Okay. So, 1 by y has to be less than equal to 1, right. This is what we also concluded here, 1 by y has to be less than equal to 1. Okay. Now, there are two ways in which this can be less than equal to 1. One is y is greater than equal to 1. Okay. This is one way. Another way is this, that y is less than 0. Okay. So, there are two solutions for this. Okay. So, this inequality will hold when y is greater than equal to 1 and when y is less than 0. Okay. Why this will hold for y equals to less than 0? When y is negative, okay, then basically this thing would become negative. So, this is less than equal to 1, right. In fact, if you think about it, would it hold for any value of y between 0 and 1? Let us say, would it hold for y equals to 0? No. If y is 0, then this would be undefined. Would it hold for anything, let us say, slightly greater than 0, 0.01? If you have something like 0.01, 1 by 0.01, this becomes 100. Now, this is not less than equal to 1. This becomes a very large positive value. And if it is, let us say, close to 1, let us say 1 divided by 0.99, even then this value is greater than 1, right. So, only way this inequality will hold is this, that either y is greater than equal to 1 or y is a negative value. Okay. So, there are two solutions, and that is exactly what we saw in the graph, right. So, this is the actual codomain of the function. Okay. So, this is what we see in the graph. Y can take any value except this range between 0 and 1. Okay. All right. So, this is how we calculate domain and codomain of a function, and this is the whole idea behind function. So, function is a process that yields exactly a single value as output based on some input. So, function is a process that takes some input and gives you some output, exactly a single value, right. So, it is a mapping from some input variable to some output variable, right. And we also saw how to find domain and codomain of a function. Domain is basically all possible values that x can take, that the input variable can take. Codomain is the set of all possible values that the output variable or the function can take. Okay. All right. Now, we will continue from here in the next lecture when we introduce inverse of a function. I will stop here. Thank you.